Good morning. I'm Nathalia. Thanks for coming. My thesis advisors are Paola Andrea Arias and Juan Camilo Villegas. Today I'm going to talk about our research, and the title is The Influence of Vegetation Activity on the Seasonality on Rainfall in the Amazon. Um, First of all, I think that it's necessary try to explain our motivation. So our idea is try to explain why the lengthening of the dry season in the Amazon. So the lengthening of the dry season in the region is present in the recent decades and is very common in the last years. So this situation leading to a regime of late onsets on the Amazon rainy season, and this situation have two explanations. The first one is about the some authors think that some explanation about this situation use a physical mechanism that involving large scale ocean atmosphere processes, like changes in the temperatures of Atlantic Ocean or the ENSO phenomenon. But other authors think that the local or regional processes, including vegetation activity, could also influence the dynamics of precipitation in this region. Our research is about the second element. We try to explain the lengthening of the dry season in the Amazon, but through the mechanism that involving vegetation activity. So our preliminary observation suggests a clear differentiation between years with long or short dry season, and is particularly interesting because the differentiation is related to energy and water fluxes, uh, all mediated by vegetation activity. First of all, we used um, precipitation data of Climate Prediction Center, daily data set, and Climate Diagnosis Center. This information is daily, and the version is SA24. This information was used to calculate the onset and retreat of the different years, the dry season of different years. And then the idea was compare with other database like era interim. So another information was precipitation, evapotranspiration, and water and energy fluxes for era interim, like sensible and latent heat and net radiation, and try to relate all these variables with a variable related to vegetation activity. In this case is NDVI. This last variable was obtained for the gyms, and all of this variable was worked in data aggregate pentats to try the reduce the noise associated with daily event. So our study region is located in the southern Amazonia, and is located between 5 and 10 south and 50 and 70 west. Well, I explain how is the mechanism to find onset and retreat for the dry season in a particular year. In this case is 1978, and the first step is calculate what is the climatological average of precipitation for the region, and then is try to calculate the onset. The onset basically is in this case, is the onset of on the rainy season is the onset of the dry season, is the same of the retreat of the wet season previous. This onset is calculated as the pentat, in which the value during 6 of 8 pentats is below for the climatological average rainfall. And then was necessary calculate to the retreat dry season, that is the same of the onset wet season, and in this case the data of the retreat it was selected what the like the value which during 6 out 8 pentat is above the climatological mean rainfall. So then was necessary calculate the length of the dry season for each year. And for this is necessary do difference between the onset of this wet season minus the onset of the wet season previous. In this figure, you can see the time series about the length of dry season for this period in the southern Amazon, and this is the average from length on dry season, and this on the red lines indicates the threshold about the mean of length, more or less 75% of deviation standard. The idea was the values above this threshold are considered years with long transition, and about the short dry season was considered years below this threshold. So the idea was compare these results with other methodology or other analysis, in this case cluster. Cluster analysis is a better option because not only includes length of the dry season in this period of time, but also include other variables like evapotranspirations, NDVI, sensible and latent heat, and is more organized the information because is more complex to in order to explain what is the situation or why is the classification better in these processes. So this is a result about cluster analysis, and these years. So this legend indicates the year, the length in pentat, and this is long, Norman, and short, but in Spanish, sorry. This classification was obtained by the previous analysis. It say this is the classification, but with the threshold of 75 standard deviation. So it's important because all of these years are organized like short and normal dry season. So it's important because in this analysis, these years are considered non-long dry season. It's important because, like I said before, this information is more is more complete or is better in compare with the previous methodology, because in this case we study other variables and not only length of the dry season. And it's important too because the classification is, in general, is perfect. And if you can see the values of the length, these years have the highest length in the total years. So it's important because the criteria of length is not included, but the classification it showed this criteria, but but indirectly in this case. And these are the long dry season. So there are our preliminary results. So our idea is try to explain what is the related or relationship between all these variables in different periods of the dry season. So this variable have this figure have 5 variables, and line blue is precipitation, gray blue is evapotranspiration, green blue is NDVI, brown line, is soil moisture infraction, and red line is the net radiation. 0 is the dry season onset, and the pentat positive is after the onset, and it is before the onset. So in the first part of dry season, this part begin decrease to precipitation and begin to increase NDVI because I have net radiation enough, because begin to increase, and I have soil moisture enough to begin the processes of evapotranspiration and the vegetation activity. And the second part is about the middle of the dry season. In this part, we think that exists a threshold about soil moisture, because in this point, you can see that the NDVI stopped to increase and begin to reduce, although I have net radiation enough. It's important in this part explain that in this part of the dry season, the evapotranspiration is feeding mainly for the transpiration, because in this part I have soil moisture enough and I have maximum of net radiation, and increase evapotranspiration, but is feeding only for transpiration. And it's necessary to say that some authors try to explain that when the evapotranspiration increase my precipitation, because I have water available enough in the atmosphere to begin these processes. So in this part, begin to increase precipitation too, but in this part, evapotranspiration was increasing too. And finally, in dry season retreat, around 30 and 40 pentat, I have the minimum soil moisture and maximum of net radiation. For this reason, increase my ET and increase my precipitation. In this point, this point is the onset of the wet season, and in this point is important because increased cloudiness. So the radiation begin to decrease because it's very difficult through the cloud and carry to soil. And finally, my NDVI decrease and reach the minimum value. So our discussion and its conclusion is basically or mainly related with what is the mechanism, but the local mechanism that can explain the lengthening of the dry season in the Amazon. Because maybe it's the vegetation, but vegetation have different processes, not only evapotranspiration and DVR, but also phenology is important too. And the idea is try to find what is the processes that do this situation. And it's important to remember that evapotranspiration is the combination of evaporation and transpiration, and one evaporation or transpiration is important sometimes in different processes. For instance, with the in the middle of dry onset, the middle of dry season, the mainly factor that is feeding this evapotranspiration is exactly the transpiration. So I think that is important, try to explain what is the local mechanism that do this thing and no more. Thank you.
Hi. Okay. It's not a question. It's like some, I don't know, some insight that you might want to compare these results with another dry or drought index, like, for example, the standardized precipitation index, to see if the classification still holds, something like that.
No, for the moment, we don't compare with that kind of index, but it's important tell us that the last analysis include rate of precipitation and rate of evapotranspirations in order to standardize these variables. These figures or the result is only about the long dry season, and at the moment we are compare what is the difference between long and short dry season to try to identify features that key features that maybe can be explained or can explain the mechanism. Thank you.